Okay, in addition to scientific notation being a useful shorthand for writing really, really large and really, really small numbers, it also makes multiplication and division extremely easy. All right, so for example, back before there were easily affordable scientific calculators, scientists and engineers used to use these things called slide rules. And slide rules basically were very good at multiplying and dividing fairly small numbers, but they were not really good at doing large numbers. But that wasn't important, because really, as long as you can multiply and divide small numbers, you can do really big and really small numbers as long as you write them in terms of scientific notation. Okay? Because in essence, multiplication in scientific notation becomes addition, and division becomes subtraction. I'll show you what I mean. Okay? For multiplication, all you have to do is multiply the coefficients. And add the exponents. And this is really the only reason in the last video I labeled coefficients and exponents, because it makes it more easy to understand this rule. You multiply the numbers out front, the coefficients, and you just add the exponents. Let me start off with something that's so simple you would never actually use this method, but I just want to kind of justify it to you that it works. Let's say we wanted to multiply 10 times 100. Okay. Well, everybody knows, we just did that example before, 10 $100 bills is 1,000. So you know that 10 times 100 is 1,000. Well, if we do it in scientific notation, though, 10 is 1 times 10 to the 1 power, okay, because 10 is just 10 to the 1 power. And then 100 is 1 times 10 to the 2 power, okay? So if you multiply these two things together, the only thing you have to multiply is 1 times 1. Okay? So it's 1 times 1, those are the two coefficients, times 10 to the 1 plus 2 power. Okay? So what you do is you're adding together the exponents, 1 plus 2. So what do you come out with? 1 times 10 to the 3rd power. Okay? So 1 times 1,000. So again, this is something that's so simple we would never use this method for scientific notation. But it works. Okay, so I just wanted to do this to justify to you that this actually is the way it works. All right, now let's do something a little more complicated. Let's say we wanted to multiply 6 million times 500. So what would be 6 million times 500? Well, again, in scientific notation, this is extremely simple. All you have to do is convert both of these to scientific notation. 6 million would be 6 times 10 to the 6th, rather. Okay, 6 times 10 to the 6th. And 500 is 5 times 10 to the 2. Okay. So you have 6 times 10 to the 6th times 5 times 10 to the 2. So what you end up with then is 6 times 5, those are your two coefficients, then times 10 to the 6 plus 2 power. So again, the only thing you have to multiply is this number out front. 6 times 5 is going to be 30. And then times 10 to the 6 plus 2 is going to be 10 to the 8th. So the answer is 30 times 10 to the 8th power. Now you might say, now wait a minute, that's not a standard way of writing it. And you'd be right. It's a correct answer, but for example, on a multiple choice test, it might not be written like that. So what you have to do is you have to say, okay, I know that there's a decimal point here. If I move it over to the left one more, then I add an exponent. This is the same as 3 times 10 to the 9th. Okay? 3 times 10 to the 9th. Right? So you see, you can multiply very large numbers very easily. If you only have a dollar store calculator that doesn't do really big and really small numbers, you can easily do the multiplication of the coefficients, and then as long as you have the scientific notation done right on the scrap paper on the side, you can multiply and divide really large and really small numbers. Okay, let's do one more example. And by the way, this is what engineers used back in the 1960s when they were trying to make spaceships that sent people to the moon. They actually used scientific notation with their slide rules to do all those calculations. So let's say we have 300,000 times 0.005. No, better yet, 0.002. Okay. So what is that going to be? Okay. Well, again, press the pause button on your computer now and see if you can do this on your own. Okay. First, you need to change this to scientific notation and then do the multiplication. Okay. I'll wait, but not very long. Okay. So let's see how we did. This is 3 times 10 to the 5th. And then this, bring it over 1, 2, 3 places to the right, is 2 times 10 to the minus 3. And then this becomes 3 times 2 times 10 to the 5 plus what? Here's where you have to be really careful. You're adding together the exponents, but in this case, the exponent is a negative 3. Okay, so instead of being 5 plus 3, this is 5 plus a negative 3, okay, which is the same as 5 minus 3. Okay, so it can get a little tricky. When you're multiplying with decimal numbers, you're adding a negative exponent, so you have to be very careful with the signs. Okay, so here you have 3 times 2 is 6. So this is 6 times 10 to the 2nd power. Okay. But again, I think you'll agree that this is a lot easier, once you get good at it anyway, this is a lot easier than trying to do it longhand where you have to do, 0.002 times 3000000, and you have to make sure all the things are lined up and where do you put the decimal point afterwards and all that. This does it much more simply and easily. Okay. So that's multiplication. Division is almost as easy. Okay. Again, there's a slight complication with division because you're subtracting instead of adding, which is always a little bit more difficult, but it shouldn't be too bad. So for division, you divide the coefficients and you subtract the exponents. So you divide the coefficients and you subtract the exponents. So again, we're going to start out with something that's so simple that you would never actually use this method, but let's just try to justify it for you. Okay, 100 divided by 10. So 100 divided by 10. By the way, in this course we will always write a division like this. 100 divided by 10. When we write something as a fraction, it's a thing on top divided by the thing on the bottom. Okay, we will never write it as 100 divided by 10 or 10 divided into 100. Okay, it's always written like this. Okay, so that's a division. So to make it simpler, let's write these with coefficients. 1 times 100, or rather 1 times 10 to the 2. And on the bottom, 10 is just 1 times 10 to the 1. Okay. So So by the way, I don't know if I mentioned this, but 10 to the 1 is always 10. Okay, 10 to the 1 is 10. And by the way, 10 to the 0 is 1. Okay, so if you ever come across 10 to the 0, 10 to the 0 is the same as 1. All right. So what we have is 1 divided by 1 times 10, and here's where it gets a little tricky, 10 to the 2 minus 1. You have to subtract the exponent that's on the bottom from the one that's on the top. So this is 10 to the 2 minus 1. So you have 1 times 10 to the 2 minus 1 power, and that is 1 times 10 to the 1, which is just 10, which we knew all along. Okay, so this is, again, so simple that we would never go through this entire process to get the answer, but I'm just trying to show you that it actually does work. Okay. All right, so let's do another example that's a little too hard to do in your head. All right, let's say you get a letter from the IRS that tells you, oh, you forgot to do your taxes properly the last few years, and you should have had TurboTax. You owe us $10,000. Okay. I got a letter like this once. It wasn't pleasant. Not that much money, thank God, but it's not a pleasant thing getting a letter that says, oh, you did the taxes wrong, you owe us money. But let's say you owe them $10,000, but to be spiteful, which is not a good thing to be, but to be spiteful, you say, okay, I'm going to pay them back in pennies. So you want to know how many pennies are in $10,000. So 0.01 divided into 10,000. What would that be? Well, again, first thing you do is change these numbers into scientific notation. 10,000 is going to be 1 times 10 to the what? Well, let's see. 1, 2, 3, 4 places, so 10 to the 4th. Okay. 1 penny, we already did that one. You bring that over 2 places to the right. 2 places to the right is 1 times 10 to the minus 2. Okay. So here you have 1 divided by 1 times 10 to the 4, and again, this is where you have to be really, really careful. It's 4 minus what? Well, you don't have a 2 on the bottom, you have a negative 2. So this is 4 minus a negative 2. Okay. So that's 10 to the 4 minus a negative 2, which is the same as 4 plus 2. So your answer then is 1 times 10 to the 6th. So you need 1,000,000 pennies, basically. So you need 1,000,000 pennies to make $10,000. And there's your answer. Okay? All right. Let's try one of these on your own. Let me give you an example that you can try on your own. $400,000 divided by 20. Better yet, 200. 400,000 divided by 200. Try this. Hit the pause button. Try this on your own. Okay, hopefully we're back now. So you bring this up to scientific notation. You have 1, 2, 3, 4, 5 places. So this is 4 times 10 to the 5th. And on the bottom you have 2 times 10 to the 2. You bring this over 2 places to the left. Okay, so you have 4 times 10 to the 5th divided by 2 times 10 to the 2. So this becomes 4 divided by 2 times 10 to the 5 minus 2 power. This is easy because there's no negative signs. You're just subtracting the bottom exponent from the top exponent. Okay. So 4 divided by 2 is, and if you use your calculator, you should be ashamed. Okay, that's 2. All right, times 10 to the 5 minus 2 is 3. So the answer is 2,000. Okay, 2,000. So 400,000 divided by 200 is 2,000. It's a very, very simple way of doing it. And once you get to, other numbers, you can just use the first couple of digits for your coefficient, and you get a nice estimation of what the actual number is. Okay? So multiplication and division, scientific notation, very, very simple.